Sometimes we have a box full of bipolar transistors and we have no idea about their polarity and pinout. This is a time when it would be very handy to have a simple device which could be assembled quickly with a few components without even requiring an expensive project cabinet. For now, we will see the principle of operation and a simple schematic diagram. As you can see, we have a 6-volt battery consisting of 4 1.5-volt batteries connected in series, either by soldering bridges or using a battery holder. We also have a series of alligator clips which are used to make contact with the electrodes of a transistor being tested. The alligator clips are identified by colors, with red being the one that goes to the collector or to the transistor pin we are assuming to be the collector. The blue alligator goes to the pin that seems to be the base, and finally the black alligator clip goes to the pin we think is the emitter. In series with the blue alligator clip is a momentary switch, normally open, which connects the bias current to the base in order to activate the transistor we are analyzing. The 10 kilo-ohm resistor in series with this button greatly limits the current applied to the base of the transistor to make sure it is amplifying. The diode on the upper left corner of the drawing is a light-emitting diode, which will light when there is a current between the red and black alligator clips. The 1 kilo-ohm resistor limits the current flowing through the LED to protect it from damage. On the other hand, the 470 ohm resistor makes the LED less sensitive to prevent it from turning on very easily, and that would yield to wrong indications. To analyze the transistor for pinout, polarity, and good working order, we start by connecting the alligators to the pins in the transistor. Suppose this tester can only analyze NPN type transistors. At this time, we don't know if the pinout assumption we made is correct, but with a few simple moves we will find out. If we press the momentary switch and that causes the LED, which can be any color, to light up, we will know that the transistor is properly activated, that the terminals are connected in the correct order, and that it is a bipolar NPN type transistor. We write down the number of the transistor and the correct pinout, and then we will analyze another transistor to get familiar with our tester. We connect the alligator clips as we did before, but suppose this time the LED lights up without pressing the button. That is, we are just hooking the alligator clips to the transistor terminal and the LED goes on. This indicates that the transistor may have a short circuit or that we have assumed the wrong pinout. What we want to do now is switch 2 pins around and press the button to see what happens. If now the LED turns on when the button is pressed, we have just discovered the right pinout. If the LED does not turn on when pressing the button, we must continue switching the pins around until the LED lights up only when the button is pressed. If this doesn't work, it may be that the transistor has a short circuit, or it is not bipolar, or it may also happen to be of the PNP type. At this point in our explanation, we cannot test the transistor as a PNP. Let's leave that transistor aside and go ahead and test another one. We connect the alligators and press the button. The LED does not light when the button is pressed nor when the button is released. A couple of changes in the order of transistor pins should make the LED turn on each time we press the button. When this happens, we have discovered the correct pinout order and that the transistor is in good condition. And of course, that we are dealing with an NPN type bipolar transistor. Regarding the order of the transistor connections, in this drawing we have the most frequently used pinout configurations. This figure can serve as a guide to find the correct connection promptly. But what do you have to do to analyze a PNP type bipolar transistor? PNP transistors are very similar to the NPN transistors, except that we have to reverse the battery. That is, we must connect the positive pole where we had the negative pole, and the negative pole where we had the positive pole. Here we have a problem. The LED indicator works only when the current flows in one direction, but not in the opposite direction. So you can place another LED in parallel and in the opposite direction as the original, so that one LED works with one battery polarity and the other LED works with the opposite battery polarity. This system has the advantage that we can use two colors for the two LEDs. The color will be a reminder to tell us when we are using the tester in NPN or PNP function. Maybe a yellow LED for testing an NPN transistor and a red LED for testing a PNP transistor. On the other hand, it is not practical to be disconnecting the battery wires and connecting them in the opposite polarity. Here we can use a double pole, double throw switch to do that work for us. When you flip this switch, its contacts move as shown, thus inverting the polarity of the battery without messing with actual wire connections and disconnections. Now, our tester can help us choose from a group of transistors those with the required polarity and in good shape, besides being sure of their pinout configuration. When analyzing a PNP type transistor, proceed in a similar way as shown previously for the NPN transistor, except that the newly added switch must be thrown to the PNP position, which we must label accordingly. I hope this information has been useful to you. Thanks for watching, and please subscribe to my channel.